I recently obtained my PhD by presenting the thesis entitled Road Safety on Italian State Roads, Transferability of Existing Models and Development of New Models. As the title suggests, the main core of the thesis is exploring a predictive approach to road safety, a topic driven by the alarming fact that every year more than 1 million people lose their lives due to road crashes globally. This led to the ambitious international goal of reducing crashes by 2030 and completely eliminating them by 2050 to reach the so-called Vision Zero. Traditionally, road safety was tackled through a reactive approach, which means taking action only after crashes have occurred. This approach has a major drawback. It only takes action after human lives have already been lost and cannot be considered a sustainable strategy both in terms of social and economic impacts. Crashes usually stem from three main factors: vehicle, infrastructure, and human behavior, and the latter plays a crucial role both as a main factor or as a contributing factor. This brings road engineers to a fundamental question: is it possible to prevent crashes from occurring in the first place? Or in other words, is it possible to design a forgiving road system which is capable of preventing human error to result in tragedy? These lay the foundations to the predictive approach to road safety, which relies on regression models to account the safety performance of different sites based on their main features, including traffic and roadway characteristics. Starting from the leading international reference, the Highway Safety Manual, one of the most challenging aspects of this research was adapting this method developed for the USA to a different study context, Italy. Unlike American roads, Italian ones have sharper curves and extremely variable character, and this is affecting the human behavior. Initially, the existing models were calibrated and adjusted to the local conditions. Then, new models were also developed to also take into account additional variables such as speed and to better reflect the local conditions. The adoption and application of these models then allowed to assess the safety performance of different roads in a systematic and quantitative way. In practical terms, the result of this thesis brought to the development of a road safety assessment tool, which can be of great support to road authorities in several crucial tasks. Analyzing the safety performances of a wide road network, assigning priority to different road sections with critical issues, planning targeted field inspections, and finally designing and planning possible interventions based on the real needs and the actual available resources. For the last step, it should also be mentioned that predictive approach has the great advantage of allowing to assess the potential impact of an intervention before implementing it, and it could be of great support to compare different alternatives and selecting the most effective one. Ultimately, the predictive approach to road safety involves a change in mindset, from reacting to road crashes to preventing them. And this shift is essential if we truly want safer roads and to fulfill the ambitious yet legitimate goal of zero road fatalities.